So why does gravity sculpt things into spheres? Well, the first thing to say is that it doesn't, necessarily. If I pick up a snowball, it's not spherical, kind of an irregular shape. As I start adding mass to it, that gravitational pull becomes bigger. So I'll get to a point where this snowball will be so massive that the gravitational pull on its surface would be so strong that it would start to squash the material out of which it's made. In this case, snow, or in the case of a planet or moon, the rock. Now you could ask the question, how much matter do I need for gravity to get strong enough to start overcoming the strength of rock and sculpting things into spheres? Well, that minimum size has got a name. It's a brilliant name. It's called the potato radius. You can see why, because things that are too small for gravity to be strong enough to sculpt them look like kind of misshapen potatoes. The great thing is you don't even need to imagine it. You can calculate it. I did that this morning and I got an answer, just roughly between 100 and 200 kilometres. The brilliant thing, the most beautiful thing, was if you look up into space and look at the moons of Mars and Saturn and Jupiter and objects out there in the solar system, you'll find that, roughly speaking, if their radius is bigger than about 200 kilometres, they're beautiful spheres. And if the radius is less than about 200 kilometres, they look more like misshapen potatoes.